Hi. Okay, now we will go to some of the identities like you can represent I in terms of R, comma, theta. How? I already told Z is equal to R e raised to I theta, and this is equal to cos theta plus I R times cos theta plus I sin theta. What you need? You need the complex number Z is equal to I, because my x plus I1 here x value is 0 and y value is 1, so you are getting I. Okay, so that is the thing. So Z is equal to I. So how to represent it? You need to get I only. So your R should be 1. And what about the theta? Theta you need it as, because this term must go vanish and this term must get 1. So sin theta equal to 1 when theta is equal to pi by 2. So you can write I is equal to 1 multiply e raised to I pi by 2. Isn't it? Am I right or not? Okay. And what about minus 1? If you want to get minus 1, because my Z is minus 1. Minus 1 means my y value is 0 and x value is 1. Minus 1. So then you get minus 1. So what about this? So here you need to get cos theta is equal to minus 1 and sin theta must vanish. So what would be the value? And R is 1, because these are all on a unit circle. Okay, I minus 1, 1 and minus I all are in a unit circle that we have seen like this. So here this is your real axis and this is your imaginary axis, and 1 here I minus 1 and minus I. Okay, so I told you this, all this will make unit circle, because wherever you point, whether this point or this point or this point, there is this wherever on this circle, if you take any complex point, if you take mod Z or is equal to mod Z, then you have to get 1. Okay, so here R is 1, then where the minus come from? Minus should come from this cos theta, isn't it? So this is 1, the magnitude 1 into e raised to what? Cos 0 is 1, cos pi is minus 1. Okay, so minus 1. Isn't it? Sorry. Okay, sorry, I made a mistake. Not minus pi, pi, cos pi is minus 1. Okay, so 1 minus 1 is equal to, this is minus 1. Okay, I made a shuffle. Minus 1 is equal to 1 into e raised to I pi. Okay, so that will give you minus 1. And if you want to 1, then what about you have to again here 1 e raised to I 2 pi or e raised to I 0. This all will give you 1. Okay, and what about minus 1? So minus 1 you have to get it from, sorry, not minus 1, minus I. So you have to get sin theta equal to minus, it should come as a minus sign. Okay, like that you can represent it. And this I told 1 I equal to 1 into e raised to I pi by 2. Or you may write it like this as well, e raised to I pi by 2 plus 2 pi. I can add any multiple of 2 pi. So that will also give the same point. So that is equal to e raised to I think it will be 5 pi by 2. Or it may be some other like that. If you add with 4 pi, then you will get another But still, whatever the point, this is the principal value argument of that is this one, this pi by 2. For this, 1 plus number I. For minus 1, pi is the argument. Okay, you may add I into pi plus 2 pi, so that is I into 3 pi. That also give you the same complex minus 1. But here also this argument is this is the or the principal y. Okay. Now we can make another identity like this. That identity is called De Moivre's theorem. So that is equal to r e raised to I theta. So equal to r cos theta plus I sin theta. What I am going to do? So this is equal to r into cos theta plus I sin theta, isn't it? I am just taking z raised to n is equal to r raised to n e raised to I n theta, isn't it? Am I right or wrong? Okay, I am right. Okay, I think there is nothing wrong with this. So I just say excuse me, r raised to n e raised to I theta is cos theta plus I sin theta. So now e raised to I n theta means cos n theta plus I sin n theta. So I am just writing as cos n theta plus I sin n theta, isn't it? Okay. Now this is the one equation. You keep it here. I can also do from here, that is z is equal to r e raised to I theta is equal to r cos theta plus I sin theta. So now I take the z raised to n is equal to r raised to n cos theta plus I sin theta whole raised to n. Okay. Now this is my second equation. I will just compare these two. This part and then this part. So what would be the result? The result is here you have r raised to n cos n theta plus I sin n theta equal to r raised to n cos theta plus I sin theta whole raised to n. Okay. So r raised to n and r raised to n gone. So what you got? You got, I am rewriting it here, cos theta plus I sin theta whole raised to n is equal to cos theta plus I sin theta whole raised to n is equal to cos n theta plus I sin n theta. And this identity you may need it at many places, and this identity is called DMOI. I think I am a little bit confused about the spelling. Yeah, I am right. It's here. Okay, so you have to remember it. This is an identity. We will use it at different places. Okay. Now, one more thing I would like to tell you today. That is roots of complex numbers. Okay. Now we studied a
few things like what is a complex number, how to represent it in a complex plane, and some of the different way like polar system, Cartesian system, and some of the identities, and all these things we just gone through. Now we will look at the roots of complex numbers. Roots of the complex number. We already have our representation. Z is equal to R e raised to I theta, or you can also write it like R e raised to I theta plus 2n phi. Now, taking the root means, for example, if you have a 4, if you want to take the square root, what do? You do 4 raised to half. If you want to take the cube root, what do you do? 4 raised to 1 by 3, isn't it? Or this is not equal, so you cannot write it as equal. See? If you want to get the mth root in any number m, then what you do? 4 raised to 1 m, isn't it? Okay. So whether you need square root or cube root or fourth or fifth, like that, whatever, mth root. I am looking at the mth root. Then I have to take 4 raised to 1 by m. So similarly, here you have z is equal to r e raised to. I am taking the general. This is most general. R e raised to theta plus 2n phi. Okay. So if I want to take mth root, then you have to take z raised to 1 by m, isn't it? That is equal to r e raised to I theta plus 2m phi 4 raised to 1 by m, isn't it? Now we will separate because this is a multiplication. So you can r raised to 1 by m e raised to I am just writing I by m into theta plus 2n phi, isn't it? Am I right? Okay. So I will just split it. R raised to 1 by m e raised to I theta by m plus 2n phi by m. So that will give you the nth root. Okay. So here this you have to if you want to find out the cube root, then you have to write m is equal to 3 here and here. Okay. So that will give you the cube root. So this is the simply the definition of nth root of a complex number. Now we will do 2-3 examples, and I will give you few as homework here. You have to do at your home. Okay. So just 1 minute. So now what you have to be careful, because here this m represents the what is called the root, which root, whether it is square root or cube root or something else. But this n, this is integers. It will take 0, 1, 2, 3, etc. Okay? But you have to be careful. You cannot take all the n values. For distinctive roots, because for a particular m, for example, if you are taking m is equal to 3, okay, there is a cube root. Depending upon the value of n, you will have different values, isn't it? Am I right or wrong? Okay. So how many roots or how many distinctive roots available that you have to check? In general, for a particular value of m, you can take the value of m equal to 0, 1, 2, etc. up to m minus 1. So that means if you have m is equal to 3, then how many distinctive roots you will get it? You will get n is equal. For example, if m is equal to 3, that means I am looking at the cube root. Then how many distinctive values you will get? Roots you will get? You will get n is equal to 0, 1, 2. Because up to m minus 1. This general thing that we know, because if you look at the square root, how many distinctive values you will get? For example, if you are looking at the square root of 4, if you are looking at the square root of 4, that means, this means you don't be confused, this is nothing but 4, okay? Then we will get only plus or minus 2 values, isn't it? So if it is a cube root, you will get 3 values. If it is a fourth root, you will get 4 distinctive values. Sometimes it merges. Okay. So here this is a general definition. If you want mth root, you will have you can take the n values 0 up to m minus 1. So if you are looking for example, if you are looking at the m is equal to 3, then how many roots? If you are looking at m is equal to 3, you will have n equal to 0, 1, 2. So when n equal to 0, you will have z raised to 1 by 3 is equal to whatever may be the value, that depending upon your complex number. I am just doing for a general case. E raised to I theta by m is 3, theta by 3 plus 2n pi by n. So n is equal to 0. Say looking for n equal to 0, the first one. That is called the first root. And n is equal to 0, so that term goes. So this is the first root. Then n is equal to 1. So z raised to 1 by 3 is equal to cube root of r e raised to I theta by 3 plus n is equal to 1. So 2 pi by 3. 2 pi by 3. So this is the second root, and n is equal to 2, z raised to 1 by 3. So cube root of r e raised to I theta by 3 plus 2 and pi. Here n is 2, so 2 into 2, 4 pi by 4 pi by 3. So this is the third root. You understand? Okay. So this is the way how to get the roots of a complex numbers. So now we will go to 1 or 2 examples, and the remaining examples you have to do yourself. Okay. Now just keep it as a reference here, and we will go. My complex number is, first example, z is equal to I. and I need what I need the square root. So what I need is z raised to half. This is the thing I need, or the square root of it. So I already mentioned how to represent this I. Z is equal to I. It is, I told R that will be always 1 for this I minus 1 and minus I, because these are all coming on a unit sphere on the complex plane. Okay, unit sphere means the magnitude is always unit. So R is 1. So 1 into e raised to I. This was I pi by 2, isn't it? I pi by 2 plus 2 and pi. So this is the principal value plus 2 and pi. Okay. Now what I need the z raised to half, or you can say r raised to half. Okay, that I need. So just here m is nothing but 2, isn't it? 2. So it will take, n will take the values 0 and 1. Okay, because it takes the values up to n minus 1. So we will just look at it. I don't know whether you can see in the screen. I hope you wrote it. I will just erase it again because I have a lack of space on the board. Okay. Then in the case of here, what you have to do, m is equal to 2, so n can take the values 0, 1, and the first root will be, I am just writing it as z01, just for my convenience. That means the first root I got it as z01. How it becomes 1 raised to 1 by 2, this one, into e raised to I theta by, so what about theta? I'm sorry, theta is pi by 2. So here pi by 2 divided by m is equal to 2. So this will be pi by 4 plus, what about the next term? 2 and pi. So n will take, first I am taking, this is for n is equal to 0, n equal to 0, so that's it. So this is the first root. Okay. Now 1 raised to half is 1 is. So this is e raised to I pi by 4. You can write it as, using your Euler formula, cos pi by 4 plus I sin pi by 4. So what would be cos pi by 4 is nothing but 1 by root 2, isn't it? Pi by 4 will be 1 by root. So this is 1 by root 2 plus sin pi by 4 also give you same value, that is 1 by root 2, isn't it? So I into 1 by root 2, or you can say 1 by root 2 multiply 1 plus I. So this is the first root. Now what about the second root? You may check it whether this root is correct or not, because if you multiply the, if you take z star, then you have to get I. Because, for example, like what are the roots of 4? That is plus or minus 2, isn't it? If you multiply 2 into 2, you have to get 4. Minus 2 into minus 2, that also you have to get it 4, like that. Okay. So if you multiply the root with itself, you have to get the original. Then you can say that is correct. for n is equal to 1, that is your second root. Here also 1 raised to half, then e raised to I pi by 4 plus. Now this is 2, n is equal to 1, 2 into pi divided by 2. So pi. This will be pi. Isn't it? So what would be the value? This is, I'm just erasing it. Okay, I hope you understand the things. This will be 1 raised to half is 1 into e raised to I pi by 4 plus pi is e raised to I 5 pi by 4. So this is equal to cos 5 pi by 4 plus I sin 5 pi by 4. Okay. So what are the values of it? So if you just check it, you will get minus half minus 1 by root 2 minus I 1 by root 2. So this will be the result. This also you can multiply itself. So it should come to your value I. Okay. So then you can say this is correct. Okay. So this is your second root. Okay. Now how to represent where it comes on the complex plane. That is more interesting. So I will just write the two roots again separately. Two roots of so for the I 1 by 2. So you have two roots. One is 1 by root 2 plus I 1 by root 2, and your second root is minus 1 by root 2 minus I 1 by root 2. So these are the two roots of square roots of this what is called I. Now how to represent it? So we will go to our complex plane. On the complex plane you have imaginary axis and the real axis. And one thing is sure, your magnitude, because this is I, the magnitude is 1. Okay, so we will look at minus, sorry, this is plus 1 plus I minus 1 and minus I. Okay, so you can connect it. Okay. Oh, okay, my circle is not that much proper. Okay, just bear with me. And the first root is 1 by root 2 plus I 1 by root 2. So 1 by root 2 will come somewhere here on the real axis. This is your real z, and this is your imaginary z, and I into 1 by root 2, that will come somewhere here. So if you look at these two over is a common point, because my circle is not that much perfect, so we have to redraw it. Okay, you connect it. I'm just making like this. This is not that much perfect, so this will be the point. What is called 1 by root 2 plus I 1 by root 2. And the second point is minus 1 by root 2. It will be somewhere here, and minus 1 minus I 1 by root 2. So it will be somewhere else. So this is join it. Because my circles are not perfect, that is why I am not getting it properly. If it is okay, then you will get exactly the common point somewhere here. So let me redraw it. Yeah. Now I hope. Okay. So this is minus 1 by 2 plus, sorry, minus I 1 by root 2. Okay. So these are the 2 points. So it actually coming as a just opposite. points. Okay, so a little bit drawing problem. Actually, this point is a mirror reflection point. Okay, so this is the way how to represent it. Now I will give you few examples you have to do at home and send to me. And also you have to draw it like this. So the first homework. First homework is you have to do z is equal to -1 and you have to do the cube root. You have to do m or cube root. Okay. You need z raised to 1 by 3. This you need. And second homework is like z is equal to -1 and fourth root. Same. Z is equal to -1 and you need fourth root. Okay. This you have to find out. And another like third one I will just give you. Z is equal to 1 plus I and you need square root, or I need the z raised to half. Okay, so these three you have to do at home and also you have to draw it and send to me, and the remaining class we will continue on next another day. Okay.